So let me welcome you to this regular meeting of the Rotary Club of Chapel Hill. We're excited to have so many people here tonight. Undoubtedly, more people will join as we go on. But the Rotary Club of Chapel Hill is not the only organization sponsoring this event tonight. And Gary, do you want to tell us about others?
Yes, I've invited everyone from Carolina Meadows, where I live, but this is dinner time for many of the seniors here. But they are a willing sponsor anytime we want to meet there. The speaker series that UNC Wellness Center and MAP sponsored for probably 9 or 10 years and had to adjourn during the COVID break is something we're trying to revive. And so this is really the first presentation in the revival. And I'm real excited about it. I hope we can have more presentations on the same topic. Tom, if you will introduce our speaker, I'm eager to hear.
Okay, well, about 10 years ago, I was arranging a speaker for another club. And I was trying to get a speaker to talk about climate change. So I contacted a professor at the local university, that was Western Michigan University in Kalamazoo, who was working on the topic. He was a chemistry professor, and I asked him if he could come talk about the climate change debate to my club. And he said no. He said, if we are starting a presentation with the assumption that there's a debate about climate change, then it's a false presentation because there is no debate. Climate change is real. Consequently, today's speaker was a lot easier to book. Unfortunately, climate change is even more real today than it was on that day 10 years ago. So let me introduce Jason West. Dr. West is a professor of environmental science and engineering at UNC Chapel Hill. He's worked on climate change and air pollution for about 30 years or so. And he performs interdisciplinary research linking climate change and air pollution to human health and energy policies. And he's currently the lead author of a chapter on air quality for the 5th U.S. National Climate Assessment, which is no minor publication.
Great. Thanks for the opportunity to speak with you all. I think that talking with the public about climate change is one of the really important things that I do, and I thank you for taking an interest in it. One of the issues we've had with climate change is it's a difficult topic to talk about casually, and so there's, in a way, too much silence around climate change. Not enough people know about it because not enough people are talking about it. And you all are in a position where you can learn and you can talk with your friends. And I thank you for doing that. I've organized my talk around 3 simple points. So what is global climate change? Why is it important? And what we should do about it. And through the course of the talk, I'll make the case what it is. I'll make the case that it's simple. Why is it important? I'll make the case that it's serious. And what we should do about it, I'll make the case that it's solvable. So simple, serious, solvable. As Tom said when he introduced me, I have been working on climate change for about 30 years, which takes me back to the time when it was sort of an oddity that you would read about or hear about in the news from time to time. The times have certainly changed, that there's a lot more public acceptance that it's an important issue. And of course, that's a good thing. But, you know, my experience goes back to well before that time. So we'll take simple first. And how is it that I can say that climate change is simple, or the science of the Earth's climate is simple? It must be horribly complex, and it is horribly complex. But when we look at the real basics of what is the Earth's climate, how does it operate, and what is the problem we face, it really is pretty simple, and I'm capable of explaining it in a few slides here. So let's go back to the 1850s or so. John Tyndall working in England and Eunice Foote working in the United States each did lab experiments where they looked at different gases and looked at their and measured their ability to absorb heat. And what they found was that carbon dioxide, but also methane and water vapor, are greenhouse gases, meaning that they absorb heat in the form of infrared radiation. But what they also found was that N2, nitrogen, oxygen, argon, are not greenhouse gases. They don't absorb heat in the same way. This was surprising to them because they understood that the Earth was kept warmer than it would otherwise be by the presence of the atmosphere. And if you add up nitrogen, oxygen, and argon, the three most important gases in the atmosphere, you get essentially 100% of our atmosphere. So the fact that the Earth is warmer than it would otherwise be is accounted for by the presence of these gases that exist in much lower quantities, much smaller quantities, a fraction of a percent of our atmosphere. And they were surprised that it was these things and not the gases that are more abundant that do that absorption. So this is a picture of the natural greenhouse effect. Our understanding of this greenhouse effect goes back, as I've said, over 150 years ago. We get energy from the sun. Some of that is reflected back to space, but much of it heats up the surface of the Earth. The Earth also gives off heat, but the Earth being much cooler than the sun is, it gives off heat in the form of infrared radiation, whereas the radiation coming in from the sun is visible or ultraviolet mostly. The difference in that this infrared radiation is absorbed by the presence of greenhouse gases. They keep some of it from getting out to space and re-radiate some of it back to the surface of the Earth. It's like a blanket around the Earth, working in the same way that a blanket keeps you warm at night. If we then increase the amount of greenhouse gases in the atmosphere, it's not a leap of logic to understand that those extra greenhouse gases will absorb more of the heat, keeping less from going out into space. That would cause the surface of the Earth to warm up until we reach the point where it was re-radiating enough heat that was causing enough to go out into space that was then balancing the solar radiation coming in. So the response of the Earth to increase greenhouse gases should be to heat up. Okay, and we've understood that for a long time, though our ability to quantify how much will it heat up remains something of an important question. I'm starting with things that we know really well that basically few credible scientists would disagree with. The second thing is that greenhouse gas concentrations are increasing. This record was started in 1957. An American scientist, Charles David Keeling, he goes by Dave, but Keeling took he created the first instrument that was capable of measuring CO2 precisely enough that you could leave it in one place for a long time and observe a long-term trend. And he started this on the big island of Hawaii at high elevation, so we're avoiding contamination from local sources. But in 1957, then within a few years, he saw this upward trend and he published that and made the world aware that now CO2 is increasing, and scientists understood pretty quickly that that was a concern from a climate point of view, to think that climate change could be real. Here's the record up to today. So when he started his measurements, it was about 315 parts per million in the atmosphere. And today we're at about 420 parts per million in the atmosphere. We can also look at ice cores and other things to look at how this record compares with CO2 in the distant past. We know that for the 10,000 years before this, CO2 was almost entirely flat at about 280 parts per million. And we know as well that as long as human beings have lived on the Earth, CO2 has never been this high. So we're experiencing CO2 higher than at any time in human history. In fact, for the past several million years of the Earth's history, CO2 has never been this high. I say also that we know that this is caused by human emissions because there's many different lines of evidence supporting that. But the first is just that we can account for how much CO2 is emitted by burning of fossil fuels. We have very careful records going back through time, how much coal, oil, and natural gas we burn through time. And that matches up pretty well with this rise. In fact, the amount of CO2 we're putting into the atmosphere would itself create a rise that's greater than this rise of CO2. It's the Earth taking up some CO2, dissolving into the world's oceans, or being taken up by plants around the world that actually cause this, this rise to be less great than it would otherwise be. The third thing that we know really well is that temperatures are increasing. So people who study global temperature records, these are from weather stations all around the world. As we go back in time, those thermometers were less precise. There were fewer of them all around the world. But so at some stations, at some locations, we have records going back several hundred years. But as a global average, the people who study this think that we have pretty good confidence that we know temperature from about 1880 to the present. And this is that temperature record that comes out, where we had a rise of temperature from about 1920 to 1940, actually pretty flat between 1950 and 1970 or 80, and then a pretty rapid rise since 1980. So we've now had 4 decades of rapid rise of temperature. What's the magnitude of that temperature change? It's about 1 degree Celsius or so from today to the late 1800s. 1 degree Celsius, call that 2 degrees Fahrenheit globally averaged. So these are things that we know pretty well. Greenhouse gases cause warming by absorbing heat in the form of infrared radiation given off by the Earth. Greenhouse gas concentrations are increasing. That's caused by human emissions. And global temperatures are increasing. As a scientist, I'd like to ask the next question. So first question, is this historic increase of temperature caused by the increase of greenhouse gases? Could there be other causes for that? What's our confidence that the increase of greenhouse gases, which again is caused by human emissions, is the major influence on the world's temperature today, or are there other factors that might be important? And secondly, what will future climate change look like, whether we increase our emissions or take action to decrease emissions? What would climate change look like under those different scenarios? So those are things we'd like to know. One of the important ways that we go about doing this is by using computer models of the world's atmosphere and climate system, and I'll talk about that in a minute. But I had some involvement with the Intergovernmental Panel on Climate Change, the IPCC. Perhaps you've heard of this. This is thousands of scientists around the world donating their time to help compile what is the state of knowledge of the climate system today. This was published just last year. These are the words that they use. So they said, it is unequivocal that human influence has warmed the atmosphere, ocean, and land. Unequivocal for a scientist is a pretty strong term. We tend to hedge our bets and say, well, there's some chance that we're wrong. So there's a lot of evidence behind this, not just that the Earth is warming, but that human influence is the most important cause of that warming. And I can show that a bit more here. So using these computer models of the climate system, the black line here are the observations of temperature, very similar to what I just showed you before. If we use these computer models with only natural forcings, so no change of greenhouse gases or other things that humans are doing by cutting down trees and other changes that are happening. If we only looked at natural changes, so the sun or volcanoes, so is the sun getting brighter or weaker through time? We have pretty good evidence that it's not, just by observing the sun itself. Volcanoes, when they erupt, cause a natural cooling influence, but that only lasts for a short period of time. You can actually see that here in the observations. 1991 was the Mount Pinatubo eruption in the Philippines. It was the biggest volcanic eruption of the 20th century. And it caused a cooling, but you see, and that is estimated here by the computer models, right? But that's small and it's short-lived. But in general, the point is that we don't have a reason to think that volcanoes are any more frequent now than they were, or bigger eruptions now than they were 100 years ago. It's only that, so this natural simulation, you have a question? I'm sorry.
Yeah, we see Krakatoa on this chart too, don't we?
That would be this one, I believe. Thank you for pointing that out. Krakatoa, the biggest eruption of the 19th century. That's right. And it happened in about 1880. Right. Good point. This simulation with only natural forcings, we have no reason to really think that that can explain, especially this rise of temperature that's happened in the last 4 decades. When we simulate in our computer models using both human increases of greenhouse gases and other changes that humans have caused, as well as these natural forcings, we get a better ability to explain these observations. There is uncertainty around these predictions or projections when we use these computer models. We don't know for sure what the rise of temperature is, but it's pretty clear that this natural only simulation can't explain this temperature rise. Again, the magnitude of that temperature rise is given here, about 2 degrees Fahrenheit. But if you go beyond what the words of the IPCC were, it's really likely that all of the observed temperature rise that we see today is due to human activity. There's really no plausible natural cause for it. Okay. Some other things from the IPCC report you might be interested in. There's been a lot more interest and evidence for and research on extreme weather events. So this was their conclusion about extreme weather events. Human-induced climate change is already affecting many weather and climate extremes in every region across the globe, including heat waves, heavy precipitation, droughts, and tropical cyclones. The next question I had had to do with future climate change and how bad future climate change would be. So this is past climate change, temperatures rising through time. Now we're using those computer models and running them into the future under different scenarios. So we don't know what future population is going to be, what sources of energy people are going to use, how much economic growth there will be, and therefore how much energy use there will be. So we've created these different scenarios from red to blue. Red would be a rapid growth scenario, both in terms of economic growth and population growth and reliance on fossil fuels. These blue scenarios, you'd really need a breakthrough of renewable energy technologies or some climate policy, a very strong climate policy to achieve these. We'll look at those questions later. But under this scenario, we would continue to increase temperature change. We're approaching here 1.5 or 2 degrees Celsius. Call that 3 or 4 degrees Fahrenheit. But under this red scenario, but under the blue ones, we eventually then stabilize climate during my lifetime, I hope, and then start bringing it back down slowly. Under the red scenarios, by 2100, we're approaching 4 or 5 degrees Celsius. That's about the magnitude of how much colder the Earth was during the last ice age, now happening very quickly over one person's lifetime. So that's a really rapid change, more quickly than happened during the last ice age. The magnitude here would be 4 or 5 degrees Celsius, call that 7 to 9 degrees Fahrenheit globally averaged. And we know that the Northern Hemisphere is likely to warm faster than that global average, and land is likely to warm faster than the global average too. Okay, to put that in perspective, I like this website that was produced by a group by Climate Central. You type in where you live. I put Chapel Hill, North Carolina. And it says here by 2100, summers in Chapel Hill, North Carolina, average summer high temperature, 88 degrees Fahrenheit, will be like summers now and it finds the place in the world that would match it, and it puts us in South Texas. So our summers will be like South Texas is today. This is under the red scenario, the most extreme rapid growth scenario that I showed you in the last chart. Just for some comparisons, I typed in some other cities here. So Boston will be like Miami Beach. Las Vegas, it had to send us to Saudi Arabia to find an analog to what it's going to be like. So those are big changes. We know that the ecology of South Texas is quite different from Chapel Hill. Many of us choose to live in Chapel Hill for a reason and not South Texas. So you can imagine, many changes in climate that would be associated with that. Okay, that's what I'm going to say about simple. I'll move on to serious. So what are the effects of climate change as it happens? And it is happening now, of course. I'll say as well that Gary and Sandy and others involved here are envisioning a series of talks on climate change where you'll get other people to fill in some of these bits on what are the impacts, and then later on, what are the energy technologies and policies that would bring it about. So I'll keep my comments there a bit short, but nonetheless, let's talk about serious. So there's many impacts of climate change that I'm sure come to mind. So coastal regions, droughts in some places, severe storms in other places. Many of these things would be likely the first things that you'd think about. And I'll talk about a few of those impacts. So what's going on in the Western United States is really exceptional. And I use that word exceptional because that's the name on this US drought monitor for this deepest red color, exceptional drought. It's never happened there. In the 150-year record of these weather data over the United States, we've never had a drought this severe, at least in these places, the deepest red color. This is a map from a year ago. Associated with that, this is Lake Oroville in Northern California. I could have picked a picture from Lake Mead this past summer. Perhaps you've seen that in the press, but this is a hydroelectric reservoir, and they shut down the hydroelectric production from the dam. That's how dry it was. So pretty extreme, and associated with that are big fires. I'm involved, I do atmospheric science, so these fires are something that we've gotten quite excited about in my field. The white here are clouds, but this is just one day in August 2 years ago. Again, I could have picked a picture from this past summer. This is a nice one. Showing a bunch of fires here in Northern California, and look at the extent of smoke from it going out over the ocean. Again, these are clouds, the white ones, but this is all smoke visible from a satellite circling the Earth. So covering and exposing the populations of many states. We've had cases where plumes of smoke have reached the eastern United States, exposing millions of people in New York City and Boston from wildfires happening in the western US. Pretty remarkable. One of the other impacts of climate change on rainfall, perhaps you haven't thought about, but if this is the climate system as it exists historically, we have rainfall events that are fairly small and evenly spread, you could say. That's good for agriculture, good for water resources. Going then into the future, what we expect are that we might have more rain in some locations, we might have less rain in some locations, but even in a place where the total amount of rainfall isn't changing, we're expecting that rain will occur in heavier downpours, and those heavier downpours will be more spread out then. That's more challenging for agriculture, that's more challenging for water resources, and it makes the simultaneously increasing the risk of droughts and floods in a given location just by changing the timing of that rain. We also have problems in California from losing snowpack off the mountains, which melts during the year and provides water during the summer. That's natural water storage that we're losing as well. And of course, Western states in the US are very concerned about that, but also think about the Himalayas and providing water for the millions of people in India and Bangladesh that drink that water. Okay. Some of the other impacts of climate change maybe you haven't thought about, but this has to do with the global poor. I'm not religious, so I'm not trying to convert you to Catholicism or anything, but This was a pretty remarkable statement from the Pope several years ago, where he produced a document really focusing on climate change. And he said that if we care about the poorest billion people on the planet, many of them are subsistence farmers who don't have other livelihood or other ways of getting food and water. And so it's them that will be most severely impacted. And so he says here, we need to hear both the cry of the earth and the cry of the poor. Another impact of climate change, maybe you haven't thought about very much, but I think is important, is from a US perspective, national security. I've shown a picture here of Hampton Roads, Virginia, the largest naval base in the world, in any country in the world. The Navy has many different, has facilities in some extremely strategically important locations around the world, and all of those facilities are at sea level. How they're going to deal with sea level rise becomes a question. But this DoD report to Congress from several years ago, I think, is important. It says global climate change will have wide-ranging implications for U.S. national security interests because it will aggravate existing problems: poverty, social tensions, environmental degradation, ineffectual leadership, and weak political institutions that threaten domestic stability. So the US military is looking at climate change as a real threat, something that can aggravate, as it says, existing problems. If you look at Syria, for example, and the conflicts that happened there, they were preceded by a historic drought that happened. People were then leaving their farms and moving into cities, out of work, and that's who ISIS recruited. The US is concerned that, again, it's not climate change that's causing these conflicts, but it can exacerbate or make those conflicts worse, perhaps dragging the United States into an international war that we don't want to be involved in. Another impact of climate change, perhaps you haven't thought about very much, is health. So this is a statement from The Lancet, the British medical journal. They did a major review on climate change and health. They said climate change is the biggest global threat of the 21st century. You know, we were living through COVID. They didn't say the spread of infectious diseases. They didn't say cancer or anything like that. They said climate change. Here is our Surgeon General several years ago saying that climate change is more challenging to public health than the polio epidemics. He says this is a new kind of threat, and he says that because there's so many ways that climate change can affect health: through heat stress, through spread of infectious diseases, through air pollution that I study, through waterborne diseases, through lack of access to food and water. So many threats going on simultaneously. The flip side of that is that we could look at opportunities for health. So if we look at the energy sector, this is something that I study. So air pollution causes about 7 million deaths per year. I'll show you a different number later, but anyways, that's what's here. Because of, and much of that air pollution comes from fossil fuel burning. The food sector, energy intensive diets, eating red meat, eating things that are high in fat and cholesterol, that's responsible for about 11 million deaths per year. Transportation sector, so physical inactivity, people are not moving very much, and that physical inactivity leads to health problems, causing about 5 million deaths per year. Many of the actions that we would take to address climate change would reduce meat consumption from cows, might address physical inactivity if we promote walking and biking, would certainly reduce this air pollution number. If you add up this 7 plus 11 plus 5 million deaths per year, that's actually about 40% of all deaths that happen globally. Not that we're going to make that go away, but the actions that we would take on climate change really do present an important opportunity. So this was, again, that same Lancet group looking at this again in 2016. They flipped it around from a global threat to saying now that tackling climate change could be the greatest global health opportunity of the 21st century. So strong words again, underlying how important climate change is from a health point of view. obviously, there's a lot more that could be said about the impacts of climate change. And if we continue this speaker series with other talks, I think you'll hear about more of those. Let's talk about solvable. So I'm not going to talk very specifically about specific energy technologies like electric cars, though I think they're great. I'm not going to talk very specifically about policies, whether it be internationally looking at the Paris Agreement or domestically looking at the Inflation Reduction Act that just got signed into law, which seems to be a pretty big deal. Hopefully some of the speakers that come later will talk about that. And if you have questions about those things, I'm happy to do that. What I'd like to do with solvable is sort of set the stage for you of why I think it's solvable, but also because I work on air pollution too, I'll make the case that we can both solve climate change and solve air pollution at the same time. So one of the things I think people don't have a good appreciation for is that CO2 has a long lifetime in the atmosphere. So of the CO2 that we emit today, I've plotted here how much of it remains through time year by year going into the future. So of the CO2 we emit today, a fraction of it is taken up within years, but a fraction of it, by the time we get 100 years out into the future, about a third of it will still be there. And by the time we get hundreds of years into the future, there's still a fraction of what we emit today that remains in the atmosphere. That makes climate change a very long-term problem in a way that we're not used to thinking about long-term problems. And I would say that our political system isn't very adept at handling and dealing with long-term problems. What other issue do we deal with on a day-to-day basis where we're thinking about the well-being of our great-great-grandchildren? But in many cases, that's what's at stake here, not only our own well-being over our own lifetime, but what kind of world we leave for the future becomes really important here. So these are the scenarios I showed you before, red to blue. On the right here, I'm showing the emissions that are associated with these different scenarios. So under the red scenario here, it's rapid growth. We're changing our emissions. This is 40 billion tons of CO2 we put into the atmosphere today. 40 billion tons of CO2. That's expected under this red scenario to about triple over the course of this century, right, by 2100. And of course, temperature change doesn't have to stop at 2100. This would be expected to keep growing. Versus the blue scenarios, what do we need to get this climate outcome, which most people who study climate change would be ecstatic if we knew that we could achieve these. We need to stop the growth of emissions and start turning the corner toward decreased emissions, eventually by 2100, reaching emissions that are very near zero, or even as it shows here, negative. We're sucking CO2 out of the atmosphere in some way. Some of the takeaways I think of from this is that this is both a big challenge. How do we provide for a growing world population, giving people the things they want, access to education and mobility and healthcare and better lives. That's what we want for ourselves and what we want for everybody. How do we do that while we bring emissions down to near zero? And yet I'll also make the case that it's solvable. It's possible to do that. So the extent of future warming is within our control. We can't make climate change go away overnight, but we can limit it to a level that would be, I'll say, acceptable, and keep it from getting worse to stabilize that climate change. And even if we're on this red scenario, one of the things we can learn is that global warming will only stop after emissions go to near zero. So it's really a question of, do we want to take the action now to bring it to zero? I'll say that being on this scenario isn't sustainable forever. The world's going to keep getting hotter and hotter and less amenable to humans existing on Earth if we keep this going up forever. So we eventually do have to get to near zero emissions. So do we want to do that now, or do we want to let climate change get worse and make those changes later. So energy is the biggest source of our emissions of CO2. Let's look at where our energy comes from. And this is one of those graphs that I think every citizen should understand really well. And yet I think by and large, our population doesn't understand it well, doesn't know what it looks like. We have, traditionally, we use biofuels, so wood. The world was powered by wood in the late 1800s. And in fact, most of the eastern United States was deforested by 1900, providing energy resources to power everything. We then turned to coal as a fossil fuel resource. We discovered oil, which is mainly used to power transportation, then natural gas. Natural gas is cleaner than coal or oil, but it's still a fossil fuel. We get, you could say 80% or so of our total energy mix comes from coal, oil, and natural gas. They're all fossil fuels. Burning them will cause CO2 to go up in the atmosphere. What's up here? So we have hydropower, important. Nuclear is not growing rapidly, but it's still a clean energy source from a climate point of view. Wind and solar are tiny slivers here, but the hopeful part of the message is that they're the most rapidly growing sources of energy that we have. Okay, I'll turn my attention for a few minutes, since we're talking about world history around energy, to talking about air pollution as well. So I'll take a step aside to talk about air pollution. This was the heart of the Industrial Revolution in England in the late 1900s. I don't know what facility this is. Imagine it might be a steel mill. And a huge amount of air pollution associated with it. You can see this looks like homes and businesses in very close proximity to this facility. So people were exposed to extremely high levels of air pollution back then. And that was the case in our country as well. This was Denora, Pennsylvania, not far from Pittsburgh, had the worst case of air pollution in US history. 20 people died over the course of a few days. This is a daytime picture with the lights on. 20 people died and a third of the town became sick. In 1952, London smog, again, a daytime picture with the lights on, became so bad that it's thought that 4,000 people died over the course of a week-long, very severe air pollution episode. So we know that air pollution is important for health. We've taken great strides in this country to solve air pollution. So these are measurements from a satellite looking at NO2, which is a marker of industrial air pollution. This is what it looked like in 2005. And look how much cleaner the air is today than it was even just that short time ago. Our environmental regulations have made exceptionally been very important in cleaning up our air. I don't think the public appreciates how far we've gotten already in improving health by cleaning up our air. Elsewhere in the world, that's not necessarily the case. This was known as the Beijing air apocalypse. These are clouds to the south here. On this day in Beijing, this is air pollution here. You can actually see air pollution spilling out through the mountain passes, overlaying the white snow that's on the ground. Pretty remarkable. This is what it looked like on the ground that day. Okay, we don't know how many people died during this episode. This is a picture from India from the COVID lockdowns. People were surprised to see when the lockdown happened and there was much less traffic and much less industries operating, how clean the air would be versus what it's usually like. We understand that today over 95% of the world's population lives in areas that exceed the WHO guideline for PM 2.5 air pollution, that's particles in the air. And most of that air pollution comes from fossil fuel combustion. I'm going to skip this. How bad is air pollution for health? About 6.7 million people die each year due to air pollution. I was involved in what's known as the Global Burden of Disease studies that helped to come up with this number of 6.7 million deaths. That's 1 of every 8.5 deaths globally. How would you think that this number of deaths would compare to, I picked a bunch of different causes of death around the world. These are ones that I'm sure you've thought about and worried about before. Would you be surprised if I told you that air pollution is the #1 cause of death on this list? And in fact, if we look at the numbers, the sum of all of 7 of these causes of death together is about 6.7 million deaths. That's as important as air pollution is as a cause of death. Many people are today surprised to see that air pollution is that important for death. All right, I'll talk a minute about a study that I led several years ago. We asked the question, if the world takes action on climate change, what would be the benefits that you would see for air pollution and human health globally? So I worked with people that model energy and the global energy system, and we estimated how the world would respond to a global carbon tax. Not that it had to be a carbon tax, but and then using methods in my lab, computer modeling, we estimated how many lives would be saved from the reduced air pollution. So by 2030, we would say we would avoid 500,000 deaths. By 2100, avoid 2 million deaths. These are the benefits in monetary terms of those health benefits. And you can compare that to the costs of the greenhouse gas control. So we were saying that the health benefits that you get just from avoiding air pollution exceed the cost of control, apart from obviously the benefits of slowing down climate change, because climate change, of course, is an important problem. I'm going quickly because I want to wrap up and hear your questions. We have a case where this is looking at the cost of electricity generation in the United States. The global energy industry is going through today what is one of the most disruptive events of the last 100 years or so. And that's come about from the drop you can see here in prices of this line is wind power going down and solar electricity going down. Solar and wind, at least in some places in the United States, are the cheapest ways of generating electricity today, cheaper than natural gas. We've had a transition from coal here. The cost is pretty flat through time of generating electricity using coal. The transition from coal to natural gas, that has been, we're still using coal, but by and large, natural gas has grown, whereas coal has decreased. That's been a benefit in that fewer greenhouse gas emissions, also fewer air pollutants associated with it. But it's this change in energy costs that are really changing things quickly. Add to that then ability to store power to account for the intermittency of wind and solar, and you can imagine a world that's powered by solar and wind as baseload power. Also, the same battery technology is enabling electric vehicles that will replace eventually the petroleum-based liquid fuel technology that we have today for internal combustion engines. So what we know from climate change going back is that we need to reduce greenhouse gas emissions to near zero this century. From air pollution, we know that World Health Organization guidelines likely will not be met if we're using much fossil fuel use. So both of these problems are pointing to the same solution, that we need to get off of fossil fuels and do so quickly. I was going to say a few words about COVID and climate change, and I'll do that if you'd like me to, because I think there's some things that we can learn from the COVID crisis that are relevant for how we deal with and manage climate change. But let me just reiterate some of the main points I've made here, and then we can hear what questions you have. So we have understood the greenhouse effect and the basics of the climate system for a long time. That is to say that our understanding of the problem is simple, to use the word that I used before. Still, there's a lot to study. The Earth is a complex system. but we understand basically what is the problem and what we can do about it. Climate change will cause widespread impacts affecting our lives, livelihoods, and the world around us in many ways that we're getting a handle on and observing as climate changes. There's a lot more work to be done to better understand what those impacts will be and inform our ability to take actions to reduce those impacts through, for example, early warning systems on hurricanes or things like that. The extent of climate change is within our control, and solutions exist today. And one of the things, going again to the research that I've conducted, is that climate change and fossil fueled air pollution can both be solved by moving rapidly toward renewable energy sources. So I'll stop there. We've got a few minutes left. Sorry if I talk too long, but I'd be happy to hear what questions you have. Stanley.
Been many studies that show that putting a price on carbon is absolutely the best way to try to control climate change. However, economists who have been beating on this for years and years have concluded that it's politically not feasible, that we have to go about it by other means, such as limits on pollution and so forth. Do you have any comments on how we control this?
Yeah, I think you said it well in asking your question, and that economists do like the idea of a price on carbon. So put a price on it the moment it's mined, and then that price signal will be sent throughout the economy. So it'll affect our electricity prices, it'll affect other things. People don't like taxes, and so it's possible to return that money that the government collects through those taxes, through the price on carbon, back to people, either through reductions in income taxes or other taxes, or there were ideas of a fee and dividend that you pay it up front, but then everybody gets at the end of the year a check in the mail, for thanking them for doing it. It provides the incentives to take the right action, but doesn't hurt people economically, at least not across the board. So economists like that idea. What was the action, by and large, that was taken in the Inflation Reduction Act? It was all carrots and no sticks. It was the government giving out money, lots of money, to the industries and to the technologies and to businesses and homeowners that are making decisions to provide incentives to make it decisions that would get us toward clean energy. It's incentives for businesses to use renewable energy, and incentives for businesses to build solar power plants instead of fossil fuel power plants, incentives for people to buy electric cars and put solar on the rooftops. So it was all carrots, no sticks. And you are exactly right, Stanley. They did that because that was what was politically possible. Is it the best from an economic or public policy point of view? Many people would say no, but we'll see what the net effect of is at the end of the day. A lot of people are hopeful it will have the effects that we hope to see. But you see, there's no guarantee that they will, right? Because it depends on people taking up those incentives and taking action as a result of it. Okay, and to the extent to which people will be motivated by those incentives, we don't know. For sure.
You have not mentioned anything about water, and yet right now we are having serious water questions about most of the Western United States through, Colorado, New Mexico, much of California, Nevada, just go through the whole thing. And I don't think, part of my family is involved in addressing some of these issues, but I don't, I don't see anybody except essentially the rural communities really getting up in arms over the loss of rainfall and their inability to get water.
Yeah, water is certainly important. Loss of precipitation, et cetera, stream flow, it's important for agriculture, it's important for livestock, it's important for all kinds of things. A lack of water causes drought, which are ecosystem impacts. It causes wildfires, which have health effects associated with it. People are displaced. The list goes on. And yet, as important as water is, and we can look at the flip side of water, right? There's places that are getting too much water that would pay you to,
Right.
during a flood, to get rid of some of that water, right? And yet, you know, as important as water is, it's one of many impacts of climate change that one could imagine. So I don't mean to suggest at all that water is not important or that climate change won't have an impact on it. Yeah, what are the places that are concerned about water? Certainly, like the California state government is. They have a growing population. Arizona is as well. How are they going to Las Vegas? You know, where's its water going to come from if more people keep moving there? Those are serious concerns. And you mentioned rural communities too. So I think many people are very concerned about water and how we'll use water in the future, right? And what climate change impacts will be. Thanks for the comment.
Well, Jason, our time has just about expired, but I want to see if you have a minute or so for any concluding comments, or shall I just thank you?
I have a question, Jason.
We may not actually have time for questions because we promised people that we would log off by 6 o'clock.
Okay, all right.
Yeah, but I'm sure that Jason will be glad to take your questions in the chat and get back to you, or you can email him.
That's
That
fine.
would be fun. I see we have mostly gray hairs on, and then just as a concluding comment, you know, climate change became an issue because of the decisions we made over your lives. I don't feel badly toward you because of that. You're all lovely people, but you know, we're in a position now where we have this awareness, and you know, we have the ability to now strike on a different path, and you know, prepare a different future for ourselves going forward. So thanks for your attention.
So, Jason, it's a more than an important topic, and your presentation delivered things in a cogent and understandable way. We certainly appreciate you coming today. I have two additional comments. One is that you showed a photo of the Pope, and I couldn't help but notice that you have a remarkable resemblance to the Pope. You may want to look back at that photo and
Never thought of that. Okay.
have a look at that. And secondly, so Widnes in England, that was chemical manufacturing. They did that. Probably particularly harmful.
Oh, I didn't know. Okay.
Probably particularly harmful for the people who are breathing that in. Yeah. So thanks so much for coming tonight, and all of us thank you. And Gary, you have something to say, probably.
I just want to thank you, Jason. You have set the stage beautifully for successive talks, and I don't know of a topic that will command greater interest. So thank you.
And we can't merely hope for the best in terms of global climate change, but we must do something to try to mitigate this problem.
Great.
Thanks, everybody, and thanks for everyone who came. And we hope to see you again sometime. If you want to learn more about the Rotary Club or the Rotary Club of Chapel Hill, you can contact me or Gary. Feel free to do that. And we should all thank Jason for coming today.
Thank you.
Yes.
Silent claps, you can do it. Yeah.
Thank you.
Bye-bye.